classification of ligands. So first of all, classification of ligands is on the basis of charge. How we are going to classify ligands on the basis of charge. So these ligands are of three types on the basis of charge. And that is basically your cationic ligand, neutral, and anionic ligand. Anionic ligand. Neutral cationic, you know that the ligands which have positive charge is called cationic ligand, as for example, NO plus, NH2 plus, etc. This is the very less used ligand in our syllabus. Neutral ligand, that is NH3, En, and then H2O, and then CO, etc. Carbonyl. These are all neutral ligands. Then comes to anionic ligand. An anionic ligand, the ligands which have negative charge. So these are all anionic ligands. So on the basis of charge, ligands are classified into three groups: cationic ligands, neutral, and anionic ligands. So please do write it. After this, we are going to talk about denticity.
We did
Yes.
classification of ligands.
We did.
Yes, sir.
Wait a minute. I think I had. We did classification of ligands as well. Can you tell me up to which part we are done with?
Sir, up to ambidentin ligands.
Okay, we are done. That means we are not done with the what we say is chelating ligand. Have we done chelating ligand?
No, sir.
Okay. So chelating ligand, write the topic, this chelating ligand. What is this chelating ligand? So basically chelating ligand is the ligand which forms a ring or closed structure. So I'm going to write the definition, write with me: ligands resulting in closed ring, closed ring structure with the metal ion are called chelating ligands. So as you can see that I'm going to take an example of En, that is ethane 1,2 diamine. So this is your ethane 1,2 diamine, which will form a ring or closed structure. NH2 is there also, NH2 is there. And you know this chelating, basically this ligand En, ethane 1,2 diamine, is bidentate. That means one ligand will form two bond. So two ligand will form four bond. That means coordination number of this is 4. And you can look at the structure of the compound, that it is closed or ring structure. Is that clear?
Yes, sir.
Please do write. Are you done with this?
Yes, sir, done.
Okay. So today we are going to start this nomenclature of this. Okay. Rules for nomenclature, how to write the name of the complex compound. It's very easy. No, wait a minute, please. Yeah, here it is. Let me know when you are able to see the screen. Here is screen. Okay. Are you able to see the screen? Ayman and Madhya, are you able to see the screen?
Yes, sir.
Okay. So look at the screen. As you can see, rules for writing IUPAC name of complex compound. So basically, as we already know that this is our complex compound in which positive counterion comes here and negative counterion comes here, right? This is positive counterion, this is negative counterion. So when you are going to write the name of the complex compound, always remember it will start with positive. If it is present, then we are going to write the name of the positive counterion first. Then jump to the ligand in alphabetical order. So you can see positive part of complex is named first, followed by the negative part. Ligands are named first. That means after positive, if you have counter ion, positive counter ion, you are going to write it name first. And if you don't have any counter ion, then directly jump to the ligand and write the name in order, alphabetical order. Next rule is prefixes bis tris tetrakis is used for complex ligand like en ethane 1,2 diamine, and prefixes mono di tri. We don't generally don't use mono. Di tri tetra is used for simple ligands like chloride and bromide, sulfate, like this. Are you getting my point?
Yes, sir.
So what you need to do, jump to the ligands and write the name in alphabetical order. And now there is the classification. If you have anionic ligand, that means the ligands having negative charge, its name end with O. Like you know that this is Cl minus, which is chloride, but since it is negative ligand, its name ends with O. Now the chloride will become chlorido. Are you getting my point?
Okay, sir.
If you have OH minus, which is hydroxide, right? Its name is hydroxide ion. But since we are going to write the name of complex ligand, what its name will be? Its name will be hydroxido. The name of anionic ligands end with O. Is that clear?
Yes, sir.
Now come to the next point. Name of anionic ligands ends with O. Now, if you have positive cation, positive ligand, if you have positive ligand or cationic ligand, then its name end with yum, IUM, like NO plus nitrosonium. It is nitroso, but its name end with nitrosonium, IUM at the end. Are you getting my point?
Yes, sir.
For neutral ligand, the name will be as it is, or there are some specific name like H2O is water, and for water we use aqua. NH3, amine is for NH3, carbonyl for Cu, for neutral ligands. Okay. So please do write up to this, and then I will explain with example. And let me know when you are done with this. Let me know when you are done with this, both of you, Madiha and Ayman.
Done, sir.
Very good. Now we are done with the, if you have positive counter and you are going to write the name of its first. But if you don't have it, then jump directly to the ligands and write the name of the ligands in alphabetical order. Before writing the name of the ligands, you need to take care of with what is the charge on ligand. If it is negative, the name of the ligand ends with O. If it is positive, then the name of the ligands end with IUM, yum. And if the name of the ligand is neutral, if the charge on ligand is neutral, then it will be as it is. Now the next part, which is very important, comes. That is oxidation state of central atom or ion is indicated in Roman numeral. After writing all the name of the ligands, you are going to write the name of the central metal atom. But before writing the name of the central metal atom, just look at the square bracket. If there is any negative charge, if there is negative charge on a square bracket, then name of central metal atom ends with 8. Are you getting my point? See, when
sir.
a coordination entity has negative charge, then the name of central metal atoms end with 8, otherwise not. Like there is a zinc, and if you don't have, if you have negative charge on the central metal atom, then the name of the zinc will be like this, zincate. Now, how you are gonna recognize where there is where the charge, negative charge is hidden? See, it will be directly written, or you can see that the charge is negative. The square bracket has negative charge, or either there will be positive counter ion. If positive counter ion is there, you are going to, if you will ionize it, there will be negative charge. So whenever there will be positive counter ion, that means there is hidden charge on a square bracket which is negative, and in this case the central metal atom's name end with 8. Is that clear? And after writing the name of the central metal atom, you are going to write the parenthesis, and this inside this parenthesis you are going to write the oxidation state of central metal atom in Roman numeral. Is that clear?
Yes, sir. It's clear.
Okay, please do write the F and E, F and G rule. Let me know when you are done with this. Are you done with this? Ayman and Madia.
Yes, sir, done.
Okay. Let's just start writing some of the nomenclature of this. Wait a minute. Okay, very good. So always remember this, how you are going to write the name. First, I'm going to explain some of them, and then we are going to see. I think you can see the screen now, right? You can see the screen now, right? So first I'm going to explain one of this. So basically it is PT NH3 whole twice H2 Cl Cl2. I'm going to write the name of it. First, look at this. Is there any positive counter ion? Yes or no? Just reply me, unmute yourself, Ayman, and let me know. Is there any positive counter ion here?
No, sir.
Madia? No. Then jump to the parent ligands. And this is amine, this is aqua, this is chlorido. So I'm going to write its name according to alphabet. So this is your diamine. Then comes water, which is known as, which is called aqua. And Cl is Cl negative, which means basically negative ligand. So its name end with O, so it becomes chlorido. After writing all the name of the ligands, jump to the parent chain. Sorry, jump to the central metal atom. Now come to this. Is there any negative charge? No negative charge. You can look. If you are going to ionize it, there will be positive charge because negative counter ion is there. So the positive charge will be there and it doesn't affect. But if there will be negative charge, the name of the central metal atom ends with it. But here there is no negative charge, neither hidden nor you can see. So the name will be platinum. The name will be platinum. And then calculate the oxidation state of this X plus 0 plus 0. Since it is neutral. Then comes -1 plus 2 into chlorine is -1 equals to 0. You can calculate it is +3. So I'm going to put platinum 3. And then after this, you are going to give some space. Whenever you are going to write the name of the counter ion, you need to give some space, and we are directly writing chloride. Don't write dichloride, trichloride, monochloride. You just need to write Cl, that is for chloride. Is that clear?
Okay, sir, it's clear.
Okay. So this is the first, just write the name of it. Then I'm going to give you this K3 C2O4 whole twice, and then comes C, that is CO, and then Cl2, and then En whole twice, and then C. Just write the name of this two. I'm waiting. Just let me know if you are unable to do it. Just don't waste time. Let me know when you are finished with the first one.
Sir, in the first question A, the one we did, diamine chloridoplatinum. What if the oxidation number is negative? Then what do we write for the 3?
If the oxidation, no, if there is any negative charge on the square bracket, then only this differs. The name of the platinum will become platinate.
Okay.
Like in this case, you can see there is positive counter ion. So we are going to write the name of it, potassium. I told you whatever is the number of counter ion, don't go with di, tri, tetra. You just need to write the name. Got it?
Yes, sir.
Wait a minute, I got a name. Potassium trioxalate, chromate oxalate. Oh, very good, very good. Now see, potassium, after writing the counter ion, you are going to give some space and jump to the ligand. And it is 3, so tri, and C2O4 is C2O4 minus 2. It is a negative ligand. So its name is oxalate, but in IUPAC, since it is anionic ligand, we will write oxalato. And then before writing the name of central metal atom, you need to look at this. You are looking at no charge. There is no charge, but there is a hidden charge. If you are going to ionize this, there will be 3 negative charge, yes or no? If you are going to ionize it, what you will get? 3K plus, and then you will be getting CrC2O4 whole thrice minus 3. Yes or no? I mean,
Yes, sir.
so whenever you will be getting generally positive counter and there is a hidden negative charge, so the name of chromium becomes chromate, and then write the oxidation state, which will be 3, and there is nothing other than the naming is completed. Okay. Is that clear? Please do the C part.
Yes, sir.
Please do the C part. No problem. I will do it. Look at this. There is no positive counter ion. Then jump to the ligand. This is chloride C. This is ethane 1,2 diamine E. So we are going to write the name of this first, dichlorido. Dichlorido, because it is a negative ligand. En is a complex ligand, and since it is 2, so what we are going to write is bis. What I told you, for complex ligand, instead of ditri-tetra, we will use bis tris tetrakis. So this is your bis, ethane 1,2 diamine. What is the name of En? Ethane 1,2 diamine. And after this, you are going to write the name of the central metal atom. Since negative ligand is the negative counter is the ion is there, there will be positive. So the name of central metal atom will be as it is, cobalt. After writing the name of the cobalt, you are going to calculate the oxidation state of central metal atom, which will be 3. You can calculate it and then close the parenthesis. After this, you are going to write the name of the negative counter ion, and you just need to write chloride. Is that clear, both of you?
So instead of ethane 1,2, can we write ethylene diamine?
What? Ethane?
Ethylene diamine.
That is common name.
Okay.
And we are writing IUPAC. Please do it and let me know if you are done with this.
Yes, sir, done.
Very good. Please write the name of this. Are you done with this, Madhya? Okay, please take your time, but do it correctly. Both of very good. Nadiya, very good. Are you, are you done with this? Thank you. Very good. Uh,
Yes, sir.
what what is the name that you have got? Ayman?
So pentamine, carbon trioxide, cobalt 1 chloride.
Pentamine. Wait a minute, please. Let me write the name. Pentamine. What is the name next?
Carbon trioxide.
Carbon trioxide. This is not carbon trioxide. Basically, it is carbonate. CO3 minus 2. You already know this is CO3 minus 2, which is known as carbonate. And since it is negative ligand, so its name end with carbonato. Are you getting my point? Carbonato. And then cobalt. And if you are going to see the oxidation state, it will be 3. And then chloride. Is that clear?
Yes, sir.
So this is how we write the IUPAC of complex compound. And the homework that I'm going to give you is NCERT exercise. You are going to do all the nomenclature from NCERT exercise. Okay. On
Okay, sir.
Wednesday, I will check it. Please write the name honestly and send it to me before the class. Okay. Can I change the slide?
Yes, sir.
Okay. After completing this, basically your writing nomenclature, then comes writing formula. How we are going to write the formula for complex compound. So there are some rules that you need to follow, which is also very easy. Just write the rule and you will get it. Rules for writing formulas. You can see rules for writing formulas. First, you are going to list the central metal atom. First, you are going to write it, then I will explain all this. Okay. Is that clear?
Yes, sir.
Let me know when you are done with this. Are you done with this?
So I can't see the last one. B.
Oh, can't see the last one. Just write up to this, then I'll explain with. Let me know when you are done with this.
Yes, sir. Done.
Very good. Both of you are done with this. Madiha, Madiha, are you done with this? Okay. Thank you. Just wait for a few seconds. Okay. Can you see a screen? Are you able to see the screen?
Yes, sir.
Now see. Write the formulas for the following coordination compound. For the following coordination compound. Now see. If you have given the name like tetra amine aqua chlorido, tetraamine aqua chlorido, cobalt 3 chloride. So how you are going to write the formula of this? First, you are going to list the name, list the central metal atom, it is cobalt. After this, you are going to write tetraamine alphabetical order. Tetra, that amine, that means NH3, and it is 4 times. After this, chlorido, that means Cl, and then tetraamine aqua is also there. So you are going to write the complex ligand that has more than one symbol, more than one letter, then it will be in parenthesis H2O and then Cl, and then write only one Cl here. First, you are going to write only one Cl here. Now, the complex compound is complete. Now, after writing this, you are going to check the oxidation state of the central metal atom first. So this is X, this is 0, this is 0, this is -1, this is also -1, will be equal to 0. According to this formula, the oxidation state is +2, but you have +3 oxidation state. As you can see, there is 3 in parenthesis that represents the oxidation state of your cobalt is 3. That means it is wrong. So it is wrong. So after writing this, just write it first like this, and then check it. After writing it, you are going to balance the charge or balance the oxidation state of central metal atom by increasing this negative counter ion. Whatever will be present, this negative or positive counter ion or the counter ion is only present to balance the charge on coordination compound. So since we have +2, so what we need to do with 1 Cl, it is +2, so we need to make it 2 according to our requirement. If it will be in need of 4, there will be 4 Cl4. Now if you are going to check it, you will see that it becomes, so this is your correct formula. Is that clear, everyone? Aman, Madhya?
Yes, sir. Got it.
Okay. So I'm going to give you 3 questions on this. Can I change the slide or are you writing it? Please do let me
Yes, sir. I wrote it.
know. Okay. So I'm going to give you 3 questions. Please do it. Write the formula of the compound. Let me know when you are done with this.
Yes, I'm done.
Okay, I'm going to write the formula. So the first formula is basically K2 Zn OH whole 4. Okay. What about this? Dichlorido cobalt is there. So CO and dichlorido, that means Cl2, and bis ethane 1,2 diamine En2. This. Okay. But here, if you are going to see the oxidation state, if you are going to, no, you cannot add something new. Madiha, Cl cannot. If there is no counter ion, you cannot add the counter ion on its own. Are you getting my point, Madiha and Aman? So if
Yes, sir.
according to this, if you are going to calculate the oxidation state, this will be x plus 2 into minus 1 plus 0, that is equal to 0. So it will be x is equal to plus 2. But here the oxidation state is 3 and we are getting plus 2. That means it's wrong. So what you need to do, if you don't have any counter ion to increase or decrease, you just need to write positive or negative sign according to your requirement. Whatever, how many ever, basically, whatever is the number in positive or negative you just need to write. So basically, this will be x plus 2 into minus 1 plus 0 will be equal to plus 1 here. Now it becomes x minus 2 is equal to plus 1. Now it becomes x plus 3. So this is the correct correct formula. Ayman, have you got the formula of this directly, correctly? Now you can see tetra carbonyl
Yes, sir.
nickel. Nickel is there. Tetra carbonyl, that means it is this. And if you are going to check the oxidation state x plus 4 into 0, you know that this what we call this CO is neutral ligand, so it's correct. X is equal to 0. Okay. Are you done with this?
Yes, sir.
Okay, so this is how we write the formula of the compound Is there any doubt in this, both of you? I'm asking from both of you. Actually, these rules and this are very easy. So I had already written in another OneNote, that's why I'm just showing you. So that some of our time will be saved. Have you written the list of what we call positive or negative ligand? You didn't have written, right?
So not the complete list, just a few.
Okay. So write this, anionic ligands are these and their names are this, and cationic, these are basically ambident ligands. In ambident ligands, when you are going to write the name of the ambident ligands, the formula will be given either like if NO2 is an ambident ligand, it will be NO2. And if it is in the form of, if O will be linked to the central metal atom, then it will be written like this. So you need to write the name nitrito N, that represents N is making coordinate bond with central metal atom. If the formula is like this, NO2 in the, if the ligand looks like NO2 like this, so you need to write, since it has negative charge, so nitrito O because it is negative, and N because it is donating from this side. ONO minus nitrito because it is negative, and O because it is donating from O side. So please make a list, write the list of this, and let me know when you are finished with this. Let me know when you are done with this. Are you done with this?
Yes, sir, done.
Both of you done with this? Very good. Now, after this, we have isomerism. and it's very easy to do. I will just share the screen. Just wait for a minute, please. Just wait for a minute. So, how's your preparation going, everyone?
Yes, sir.
How's your preparation going?
Sir, it's going slow.
It's slow. What about you, Madiha? Okay, let's start this part, a new topic that is isomerism. And we are aware of this isomerism. What is isomerism? So basically, same chemical formula having different structural formula, that is isomerism. So just do let me know when you are able to see the screen. I think now you are able to see the screen. Can you see the screen?
Yes, sir.
Okay. So basically, what is isomerism? So as you can see, I already have written that compounds having same molecular formula but different arrangements of atoms, due to which they are differ in one or more physical properties, that are called isomers, and the phenomenon is called isomerism. Now here, isomerism are of two types. Isomerism are of two types. One is a structural isomerism and another is a stereoisomerism. So just write it and then I will explain one by one. Okay.
Okay, sir. Yes, sir. Done.
Very good. Now see, this structural isomerism are of four types. The one is solvate or also known as hydrate isomerism. The another is ionization isomerism. The third one is linkage isomerism. And the fourth one is coordinate isomerism. And as stereoisomerism are of two types, geometrical and optical isomerism. Are you done with this chart?
No, sir, I need to do this bottom half.
Okay. Then I will explain one by one all these isomerisms.
Yes, sir, done.
Let me know when you're done. Okay. Now see, this is structural isomerism or solvate isomerism. What is solvate isomerism? Basically, this is also known as hydrate isomerism. And it's very important to note that isomerism, which has different in number of water molecule. When it is different in number of, when there will be difference in number of water molecules as ligand and free solvent molecule in crystal lattice. As you can see, this is your first coordination compound. Now there will be exchange. There is 6 water ligand, H2O aqua ligand. Now there is H2O 5. But overall coordination number you can look at is this will be 6, and their coordination number is also 6. But the difference is that there will be exchange of solvent or water with the counter ion. There is 3 Cl, so you can see there is 1 Cl and H2O whole 5, and there is exchange between counter ion and ligand, and the exchange only takes place of water. That is known as solvent isomerism. Is that clear?
Yes, sir.
Overall, the uh, formula is same. Aman, are you done with this?
Yes, sir.
Okay. So this was your solvent isomerism in which exchange of water took place. Now the next is ionization isomerism, and it's very easy. If there will be exchange between any other, wait a minute, my headphone is this. Am I audible? I'm am I audible?
Yes, sir, you are.
Okay. So what is ionization isomerism? If the exchange between ligand and counterion takes place other than water, other than aqua, other than H2O, that is called ionization isomerism. Look at this. The formula will be same, but there will be exchange between counterion and ligand. So this type of isomerism is known as ionization. If the exchange of water will take place, then it is solvent or hydrate isomerism. Okay. Please do write it. Are you done with this?
Yes, sir.
Okay. Now come to the next, which is coordinate isomerism. Basically, here there will be coordination between these two, and the coordinate basically ligands changes. Now this is the first complex compound CrNH3 square bracket CO CN whole 6. Now the ligand of them will be changed. This ligand will come to here, and this ligand move to there. Now, as you can see, same chemical formula, but different structural formula. So this type of ligand is known as, this type of isomerism is known as coordinate isomerism. Due to exchange of ligands between cationic and anionic coordination sphere. Is that clear? Please do let me know when you are done with this. Are you done with this?
Yes, sir, now I'm done.
Done. Now the next is linkage isomerism, and linkage isomerism is only for your ambident ligands. As you can see in this case, central metal atom or ion have different linkage with ambidentate ligands. So basically NO2, that means the linkage is from N to central atom, but NO2 can be written as ONO. That means the linkage is between O and central atom. All the part are same, only this part will be different. Are you getting my point?
Yes, sir.
So please do write it. In the next class, we are going to complete this stereoisomerism along with VBT, that is valence bond theory.
Okay, sir.
Let me know when you are done with this.
Yes, sir, I'm done.
Okay. So see, this is it for today.